From the age of 6 we are taught math, yet most of the things we are taught don't apply to real life. Or do they? Have you ever wondered if math can apply to simply throwing the ball? So today me and my group will put that into the test.
But before we begin any experiments, here's a little background knowledge on what a differential equation actually is. A differential equation is a mathematical equation that relates to some function with its derivatives. In applications, the functions usually represent physical quantities, the derivatives represent their rates of change, and the equation defines a relationship between the two. Because such relations are extremely common, differential equations play a prominent role in many disciplines, including engineering, physics, economics, and biology. So here's Alan to explain more of what we're talking about.
As you can see from the video, a ball was thrown by Connor, and it's much more than that, as the ball flows through the air and follows a trick, which you can simulate through mathematics. Let's put this into the XY coordinate system. The place that Connor is standing can be represented on the plan by 0, 0, which is the original point. However, because Connor is around 2 meters tall, the ball will be thrown from 0 to. After the ball is thrown, it follows a path, which can be represented by a quadratic function that's equal to y equals minus x to the power plus 3x plus 2. Next, we'll use a different mathematical method to figure out this highest point the ball reached. This is done by deriving the function and make it equal to 0. First of all, we find the derivative of the function, which is y dash equal to minus 2x plus 3. We then make y dash equals to 0 and solve for x, and this gave us the stationary point, which will be either a max or a min. We found that x is equal to 1.5 and then substitute the value back into the original function, which gave us y equals 4.25. This means that when throwing the ball, the maximum height is 4.25 meters. Now Connor will explain how far the ball will travel.
Once the ball hits the ground, the process is done, and the horizontal distance between the original point and the landing point are determined. However, in order to find the exact distance the ball travelled from its original point, we must make the original quadratic equation equal to 0 and solve for x. We then used factorization and found two answers for x, which were 3.56 and negative 0.56. But how can there be two answers? One way of cancelling out one of those answers is by thinking logically. There's no such thing as negative distance, therefore negative 0.56 is undefined, and 3.56 is our final distance travelled.
As you can see in the experiment, when Connor throws a ball with the curve function represented by y equal to minus x squared plus 3x plus 2, the maximum point the ball can reach is 4.25 meters from the ground, and the travel distance is 3.56 meters. When doing any mathematical or scientific experiments, you must take many assumptions into consideration. For this particular experiment, we assumed that the ground was flat, there was no wind affecting distance travel, and we assumed that the ball weight. Any changes to this assumption would affect the end result. Now let's explain our application for differentiations. Differentiations can also help us solve many other types of real-world problems. We can use derivative to determine the maximum and minimum values of particular functions. For example, cost, strength, amount of material used in a building, profit, loss, etc. Derivatives are also made in many engineering and science problems, especially when modeling the behavior of moving objects. That's the end of our video. Thank you for watching.